Today we're going to be learning about the discriminant. So before I tell you what the discriminant is, let's talk about the four different types of solutions that you get when solving a quadratic. So you can get one real rational root, and remember root is the same thing as solution, one real rational root. You can get two real rational roots. You can get two real irrational roots, and you can get two imaginary roots. Real means they're not imaginary. Another word that they sometimes use for imaginary is complex. Remember, you can pause this video at any time if you need more time to write. All right, so let's solve and give the type of solutions. So these are in standard form, so I'm going to do the quadratic formula. Opposite of b plus or minus square root, b squared minus 4ac all over 2a. So that gives me 5 plus or minus, when you put all of that in the calculator, you get 1. So the square root of 1 over 6. 1 is a perfect square. The square root of 1 is 1. And these are all just numbers, no i's, no square roots, so I can continue simplifying. 5 plus 1 is 6, divided by 6 is 1. 5 minus 1 is 4, divided by 6, reduces to 2/3. So you get 1 and 2/3. So I have two solutions. They are real. There's no i's. They're not imaginary. And 1 and 2/3 are rational numbers. You can go back and watch the video on rational and irrational if you need to. So this one has two real rational roots. Or you could say two real rational solutions. Remember, the other word is also x-intercepts. So if I put this one in Desmos, 3x squared minus 5x plus 2, and I need to zoom in so I can see it better. The x-intercepts are at 2/3. You got to be careful. Desmos will give you a repeating decimal, which I will count incorrect. So you got to make sure you know that that's 2/3 and 1. So it has two x-intercepts, and they are rational numbers. All right, let's do another one. X squared plus 9x plus 3. So opposite of b, plus or minus square root, b squared minus 4ac all over 2a. 2 times 1 is 2. So 81 minus 12 gives us 69. All right, 69 is not a perfect square. And there are no perfect squares that go into 69. So I have to leave it as the square root of 69. So this is my answer. There are two of them. There's one that you get when you add these, and there's one that you get when you subtract it. So there's two answers. They are real. There's no i's. But the square root of 69 is an irrational number. So this one has two real irrational roots. Once again, if you put the original quadratic in Desmos, it has two x-intercepts, and they are irrational numbers. And again, Desmos, you're not going to be able to do all the work. It's a good place to check your answer, but you can't really tell that these are irrational numbers because Desmos only goes to the thousandths place, and an irrational number goes on forever. So these are the approximations that Desmos is giving you. All right, let's do another one. X squared, 8x squared minus 4x plus 1. Opposite of b, plus or minus b squared minus 4ac all over 2a. So when I put what's underneath the square root in my calculator, I get negative 16. Anytime you have a negative under the square root, you have to pop out an I, and the square root of 16 is 4. These will all reduce by 4, so 1 plus or minus 1i over 4. You divide all of those by 4 to reduce it. So this is my answer. Since it has an I, there are 2 imaginary roots. 2 imaginary roots. Another word they use for imaginary sometimes is complex. All right, let's type this one into Desmos and I'll show you what happens. 8x squared minus 4x plus 1. Notice this one has no x-intercepts. It never crosses the x-axis. So therefore, its answers are imaginary. All right, there are no real x-intercepts. They are imaginary. So anytime it doesn't cross the x-axis, it's going to have imaginary roots. All right, and let's do this one. Opposite of b, plus or minus b squared minus 4ac all over 2a. 40 squared, negative 40 squared minus 4 times 4 times 100 gives you 0. The square root of 0 is 0. And when I simplify that, 40 plus 0 is the same thing as 40 minus 0. So there's only one answer. There's only one answer. 40 plus 0 is 40 divided by 8 gives you 5. There is only one real rational root. And anytime there's only one answer, it will always be real and it will always be rational. All right, so let's look at what the graph looks like for this one. So we can make connections. 4x squared minus 40x plus 100. Notice this one only has one x-intercept, so our work matches the graph. So for these, we just did the whole quadratic formula to see what types of roots they have. The discriminant is a shortcut. The discriminant is a shortcut. All right, so the first thing you might ask is, what is the discriminant? What is that even talking about? What is the discriminant? The discriminant is b squared minus 4ac. It's what's underneath the root. It's what's underneath the root. And I don't know if you've already noticed this, but what is underneath the root determines your answer. What's underneath the root determines what type of answers you get. If the b squared minus 4ac is equal to 0, if it's equal to 0, you're only going to get one real rational root. Anytime what's underneath the square root is equal to 0, you get one real rational root. That happens every time when you get a 0 under the square root. And the graph is just going to have one x-intercept. All right, let's talk about other scenarios. If the b squared minus 4ac, if what's under your square root is less than 0, that's going to give you a negative number. And so you'll have to pop out an I. So you'll get 2 imaginary, or they sometimes call them complex, roots. Okay, and how does that look on a graph? Well, since they're imaginary, it means the parabola never touches the x-axis. Never touches the x-axis. All right, if b squared minus 4ac is greater than 0 and a perfect square, you're going to get 2 real, that means they're not imaginary, rational roots. Perfect squares give you rational numbers, okay? And so that's going to have 2 x-intercepts, and they're going to be at nice, pretty rational numbers. All right, and the last scenario is greater than 0 and not a perfect square. And that's going to give you 2 real irrational roots. So once again, the graph will cross at 2 places, but it's going to be at decimals that go on forever and not nice and pretty numbers. All right, last part of today's lesson. Find the discriminant and tell the type of solution the quadratic will have. All right, so all we are doing is finding the discriminant because the discriminant is a shortcut to tell you what type of solutions you will have. So the discriminant is b squared minus 4ac. So negative 2 squared minus 4 times 1 times 5. That gives you negative 16. Well, if you get a negative answer, it's going to have 2 imaginary roots. If you get a negative number, it's going to have 2 imaginary roots because you would have to pop out an I when you did the whole quadratic formula. All right, let's do another one. Ooh, this one, 15x squared equals 10x minus 1. You've got to move everything to one side. So 15x squared minus 10x plus 1. All right, now I'm just going to do the discriminant. B squared minus 4ac. So negative 10 squared minus 4 times 15 times 1. That gives you 40. 40 is a positive number, but it is not a perfect square. So you're going to get 2 real irrational roots. Okay. And this one, third example on this part, once again, you got to move the 3. So 2x squared plus 5x minus 3. So I'm going to do the discriminant, b squared minus 4ac. So 5 squared minus 4 times 2 times negative 3. And that gives you 49. 49 is positive and a perfect square. So that gives you 2 real rational roots. All right, and the last one. Ooh, we've got to move stuff and combine like terms. So we've got to add 4x squared and we've got to subtract 4x. And we're going to combine like terms. That gives me 9x squared minus 6x minus 1 equals 0. All right, I'm going to do the discriminant. Negative 6 squared minus 4 times 9 times negative 1. And that gives me 72, which is positive and not a perfect square. And so that's going to give you 2 real irrational roots. The only example I didn't do was one that the discriminant equals